Okay, welcome to the Humber College Student Learning Services, and we're the Math and Writing Center, and the video for today is limits and continuity. So what is a limit? Limit describes the behavior of a function as it approaches to a particular input. Okay, so basically, the limit of fx as x approaches to value a is the value that fx approaches as x is closer to a. So the notation wise, we're going to write it like this. Okay, so I believe this notation is straightforward enough. We're going to start with an example of understanding what is a limit. So suppose we're given the graph looks like this. But remember at 1, the function is undefined. Okay, but it turns out that it doesn't matter because the limit of this as x approaches to 0, 0 is the input here, is actually 1. Although it's not defined at 1. Why? Because for limits, we don't care about the actual output, but the trending behavior. This is a key characterization of limits. So you might ask, when do we care about the input? Well, this is the matter of continuity, and we'll go to this later. Okay? So here's an example. We want to calculate this limit of this as x approaches 3. So you might just plug in x equals 3 in it and see that, oh, this is undefined, but remember, we can simplify this expression, right? We can cancel this x minus 3. But why we can cancel all this is because that as x approaches to 3, x will never equal to 3. So that is why we can cancel it out, right? And then we have this expression. And for this expression, we're safe to plug in, right? Because if you draw a graph, you'll see that. If you draw the graph of this expression, you'll see that, oh, it is safe to plug in because the limit is just the one that you expected, right? So here, another example, right? Again, we use the difference of squares to cancel out the x minus 5 because x approaches 5, x will never be equal to 5. And then we plug in, okay? Okay, so besides for limits, we know that it is a two-sided behavior, right? It can approach from this side or this side. So for that to distinguish this, we have a thing called one-sided limits. Limits are considered the approach from only one direction, either from the left or the right, are called one-sided limits. Okay, so if x is a negative, means that the limit as x approaches to a from the left, which is the negative side direction of a. A positive means approaches to a from the right. So for example, consider this function, fx is 1 over x. You'll see that as x approaches 0 from the positive side, which means that if x is really, really small but is positive, then 1 of x will be very, very large. But what if fx approaches 0 from the negative side, which is x is a very small negative number, then x will be very, very close to like negative infinity, right? So we have these two results, right? We have those two things. So you might ask, what is the limit of this as x approaches to 0? Well, if it's from the positive side, it is positive infinity. If it's negative side, it's negative infinity. So you might just say, like, what is the limit? The limit turns out to be does not exist. Okay? So for example, we have this function. For x less than equal to 1, it looks like this, right? And with the input at 1, and a greater than 1 is just equal to x. Okay? This limit at 1 dne. dne means does not exist, right? Although the left and right side limit at 1 exists. The limit at 1 is 2, right? Approaches from the left. Approaches from the right it is 1, right? So 1 is 2 and another one is 1, which means that they're different. So the limit at 1 does not exist. But for continuity, a function is considered a point at a if the following conditions are met. fa is defined, okay? At the point a, fa is defined. And the limit at a exists, means that the right side, left side limits are both exist and equal. And lastly, the limit at a must be equal to the output at a. If these conditions satisfied, we say that the function is continuous at a. Okay, so for example, this is a new example, but still, consider this function. To determine if f is continuous at 2, we check the three conditions, right? So first of all, f of 2. Well, f of 2 is not defined, right? Because we're division by 0. So at the first time, you can just like conclude that, oh, this function is not continuous at 2, right? Well, for the second condition, it is all the limit exists, right? The limit approaches to 4. But note that the first condition is not defined, right? The first condition is not satisfied, so we can already conclude that this function is not continuous, right? So that is the end of this today's video, and I'll see you guys next time.